I think we're ready. All right.
Yeah, we are ready.
Okay. Take it away.
Sounds good. Hi everyone. My name is Pierre Brunelle. I'm the co-founder and CEO of a new project called Pixeltable. Pixeltable is an AI data infrastructure for multimodal workloads. So we are open source project available on GitHub. I'll share my screen in a moment and walk you through what it is about. So as you can see my screen, this project has been started 2 years ago by Marcel Kornacker, who is the co-creator of Apache Parquet and also co-founder of Apache Impala. So we'll walk you through how we developed and used Pixeltable to help with multimodal AI apps development. So something to know about multimodal AI app, it's really the core development challenges that people faces with it. First, you have to work with different data types. You have to store, transform, index, and iterate over data with different types such as text, images, video, and audio. People have difficulties in traditional ML use cases, but as well, even more with those multimodal use cases to track changes, and as well as maintain data lineages from the raw data to the data that's being transformed and augmented to actually the model output. It is difficult to scale when you have to manage all those different data stores, data types, and requirements in production, and therefore it's difficult to move from development to production as well. So the genesis of Pixeltable by Marcel is really thinking about how you can provide a unified interface to cover the entire ML lifecycle within the data store itself. So it's a unified data storage that provides a way to handle data transformation, data movement, model inferences, while providing you all the benefits of a database itself. We built it, and it's open source, like I said, on GitHub for ML engineers and data scientists who want to focus on the algorithm and the model. And you don't have to focus on the infrastructure and the data plumbing. Pixeltable take care of that for you. The core principle is, like I said, really letting you focus on the model, the data augmentation, the data wrangling, the embedding model that you might want to train and use yourself, how you want to deploy the data, how you want to create the data, and not have to focus at all on the orchestration aspect. Today, you see a lot of teams and companies who are spending a lot of time with in-house scripting, building their own infrastructure for data management, usually sitting on the blob storage and RDBMS solution. So it's really what Pixeltable is addressing. It's not a low-code or no-code environment for non-technical users. You still need a lot of technical skill set, mostly Python, in order to interact with it. Like I said, Pixeltable is a database system, so it's built for all your data type. We handle storage and compute, which means the data itself resides in table, and the tables are persistent. So it's very differently from pandas or polars or daft, where all you play with the data frame, and the data frame is a container for the data itself. In Pixeltable, there is a data frame veneer, but the data frame is simply a temporary view, a temporary table of your data. It's handling lazy evaluation, which means you only get the data until you collect the actual query. Every data transformation, model inference, and custom logic are declarative, which means you can simply declare with the Python SDK what you want to do, and we'll see that in a moment. We handle every data types, the most common ones such as numbers, text, time, and Boolean, but also images, video, audio, documents, which you can insert through local files, URLs, blob storages, making it easy to cover all the use cases that an AI app developer and ML engineers might want to start with. We have specific types such as arrays or JSON nested structures, which are very practical when, for example, you store vectors. In terms of a technical architecture, so to be able to handle data model and inferences, it's built on top of Postgres and pgvector for structured data and embeddings. It is really just an implementation details for Pixeltable. It is something that could be swapped with another database system in the future. but it is a building block to the experience that we provide. When you pip install Pixeltable, it's installing a Postgres server instance on your machine. There is no need for Docker container. We leverage something called PG server, which is also available as a repo in our GitHub organization, which give you, when you pip install on your machine, a Postgres instance, a local file system that store all your media file with a caching handling, which means that when you work with frames of the video, for example, or large images, there is a caching system to make sure that they only materialize and use at runtime for the inference or the processing needed, and then they are evicted. You can decide to preserve them as well. Lazy evaluation, I mentioned that, and we'll see the notion of computed columns, which is also a notion that you can see in databases, but they're a bit more complex in Pixeltable, as well as the UDFs. And our DAG is actually constructed as you use Pixeltable. It's all used through Python SDK. So like I said, Pixeltable is an orchestration system, and here we are looking for the first time at the code or how to use it. So here I'm going to create a video table, and I'm gonna use a video variable and say pxt.create_table videos. That's the name of my table. There is only like one column in that table. It's gonna be a video column that I call video, and I use a video type. So this is the schema of my table. What I'm doing here is deciding that the video that I will insert in that table, I want them actually to be transformed and processed through a view, which is going to be a materialized view on that base table, in order to chunk them into frames. What do you want to do that? It's very common in multimodal workloads with video, with images, with document for RAG to want to work on a chunk of an element. So let's say you want to work a chunk of a document, or you want to work on a piece of text like paragraphs, sentences, headers, or you want to work on the frame of a video when you have computer vision use cases such as, pardon me, such as object detection, segmentation. So what people are usually going to do, they're going to write some script using CV2 and other open source libraries when they're going to take the video, chunk them into frames, put them in a list, use the different models. Here we are using YOLOX, which is an open source model, and apply the detection onto those frames, and then rematerialize those frames into a video in order to see a video, for example, of cars moving around with their dry boxes surrounding them. All you need to do in Pixeltable here is creating a table, creating a view on that table, which takes care of building that DAG that is mapped onto that table structure with a dependency, which means that Pixeltable knows that as a video is inserted in the base table, that video will be shrunk into frames. As you see, we iterate over the video column of the video table. And then we will apply a detection model. I just create a computed column called detections here, and we'll apply YOLOX, which is a built-in function. Again, as we will see, you can write your own UDF in pure Python code, and you can apply any model, transformation, inferences on the data sitting in your table. Here I'm using YOLOX and applying it on the frames column of the frame view. Pixeltable is also vector DB, which means as we use Postgres, you can basically seamlessly do vector search. What's very valuable about that is having the vectors collocated with the data, which means that there are two core things here. One, the embedding indices are actually created and maintained as you add new data. So you have incremental updates of your embedding indices, which means that the same way you declare the embedding indices, like in a declarative way as to any table columns within your table, and you can decide which model to use. Here we are using, I'm not showing the setup code lines, but we are using clip from OpenAI, and we're using clip images and clip text in order to do similarity search. So you can do similarity search on using images or using a text. As you can see here, I'm using text red car, and in order to fetch the result, I'm just ordering by similarity, and I'm returning the 5 top frame. Like I said, Pixeltable is incremental, which means data transformation, model inferences, and custom logic will incrementally update as you add new data. So for example, when you think about adding rows incrementally to your table, every computed column in that table will be populated for the new rows coming in. This, in the same way as I described, indices are automatically maintained and reflect the new rows. So the big benefits around that, as I mentioned, of being declarative, multimodal, and incremental for your multimodal use cases is you have zero manual pipeline management. It's automatically tracking all the dependencies, and you benefit from the fact that the table are versioned, which means every input, every output in your table, it's something that you can go back to, something that you can revert in order to work with different experiments or side-by-side comparing different methods as you iterate on your multimodal AI application. Pixeltable is extensible. We want to have Pixeltable focusing on taking care of what you don't want to work on, which is the whole orchestration and plumbing of the data. But we want you to let you use your own framework the way you want to use it, which is what we wanted to make sure that the UDF is very easy to use. So you can simply wrap up your own pure Python code as a Pixeltable UDF using the @pxt.udf decorator. And like that, you can define any type of function that you want or processing that you want and use it as part of your workflow. The same way you have seen us using YOLOX or embedding in a previous setup, those are UDFs that are just already in the core packages that we have developed ourselves to make it easier for you to use those built-in methods that you know you are using a lot. Here, as an example, it's not a complete UDF, but I was showcasing you that you can define a custom model, returning that prediction of that model, and then you can use it in a computed column by simply calling that UDF, deciding the input, which is usually a column of a table of a view, and then query the result of that UDF using our lazy evaluation and query language here, which is very similar to what you can see in Polars, when you can just do a select, where, and collect. If you think about beyond the basics, that's what I didn't cover today, and then I will switch to an example. You can think about Pixeltable as something that also provide you with version control. Like I said, there's full lineage tracking. There's a notion of snapshot management as you want to build and manage your features. You can create a snapshot view, which enable you really to track your experiment as you work on augmenting your data, transforming your data, and using it for model management. Views, we really went pretty fast on the concept of views for complex data transformations, and also on the rich query language, which provide you like a data frame-like interface to work with all your multimodal data. Where Pixeltable is at today, like I said, it's available on GitHub as an open source packages. It's focused really on local development. By experience, I've seen a lot of people struggling with remote cloud workloads, and I think it's very important to enable local feedback loop for ML and AI development, which is why that's the core focus on today. There is a full feature set for enabling users and teams to build RAG implementation, to build computer vision use cases and multimodal workloads, like we are going to see in a moment. And in the 2025, we're going to focus on building in open source multimodal data sharing capabilities to show that you can use tables that are reproducible workflow that you can share with others. Parallelization and concurrency to ensuring scalability and performance. Providing a local UI so you can introspect into your databases, such as the Postgres instance that's sitting on your local machine, and look at the schema, look at the column lineage and the dependencies, and also model versioning to make sure to complete the ML lifecycle. So I'll stop sharing for a second. I'll switch to an example with the time that's left. a part if we can take questions. Jim, you let me know if there is questions. If not, I will switch to an example.
Yep. Yeah, I'll let you know if there's questions, and I would encourage anyone in the audience to post the questions in the Q&A tab, and we can read them as they come in or save them to the end.
Sounds good. So I'll switch to an example using Hugging Face Gradio apps to show you that it's very easy to actually build apps leveraging Pixeltable entirely. So what I'm going to show you here is we have seen how to, pardon me, we have seen how to create tables, insert data, the notion of being declarative, multimodal, and incremental. What I'm going to do here, I've built a very simple Gradio app where I'm going to insert a snippet of Mission Impossible #2, which, if you ask me, is the worst Mission Impossible out there, out of the 7 that there is. And so what I'm doing here, as I'm inserting the video into the video table, it's automatically going to chunk that video into frames. It's going to apply an embedding in this index on as a computed column, as an indices, and then it's going to basically allow me to search those frames using the multimodal input such as text or images. So I'm going to search for Tom Cruise here, and you're going to see that very rapidly it's going to perform the search and find the different frames where Tom Cruise appears in that excerpt. I can search for men as well, and you will see Tom Cruise again. I can search for woman, and you will see the woman in the excerpt. I can insert an image, and hopefully I can find an image of Tom Cruise on my laptop, which that's all I have on my laptop. And you can see it's gonna find Tom Cruise as well. So we have seen the snippets of the code in the slide deck already. It is actually very easy to set that up, simply like I mentioned already, by creating a table, like in the example, creating a view on those frames, then inserting a video into the table, which will chunk the video into frames, and having an embedding index to then search on that embedding index. So it's exactly the example I provided you on that slide deck to show you the different functionality of Pixeltable that powers completely this entire application. There's another application I want to show you here. For example, that's going to be around, let's combine video with LLM. I'm gonna take like a video of like Fragment podcast of 1 minute. I'm gonna say, okay, let's take that video and try to make a tweet out of it. So what we are doing here, we are inserting the video into a table. We are actually using a functionality to extract the audio of the video. Then we are transcribing that audio into text. We are sending that text to an LLM. We are then asking them with a prompt to basically generate a social media post. And you can see here, all I've done is inserting that video, extracting the audio. As you can see below, I can play it here. The transcription as well is here. We use Whisper for the transcription. Here's the frame that I extracted. And here's the LLM by having the transcription being passed onto the LLM. So this is a very complete use case, very simple one. But again, completely relying on Pixeltable, providing you with versioning, lineage, computation, orchestration, simply by creating tables and views and columns and UDFs that takes video, audio, text, interact with Whisper, an LLM, and give you the output that you need. And you can retrieve images, text, audio, and build any application that you want. So that's two very simple use cases. I can wrap up with one part if there is question. Let me wrap up with another one. let's take an LLM use case. Go ahead, Jim.
Yep, I was just gonna say there's one question if you want to take it now.
Yeah,
Question.
let's take it now.
Yep. All right, I'll show it on the stage. How do you see the Pixeltable comparable notebook LM?
That's a great question. So I see Notebook and LLM. I see Notebook LM simply as an application that you can build using Pixeltable. So in the GitHub repo, you can, for example, go check out. I can share my screen and show it to you right now. There is a couple of examples in the docs and sample apps. So for example, here I have a bot with infinite memory, or I have the text and image similarity search that I've built using Pixeltable. So see Pixeltable as a data infrastructure that you might use to build Notebook LM. Let's say you might use it because you might have multiple tables per project. You might have views that's going to chunk your document or videos or images into segments. You will build column to process that data, and then you will query using the query language to return the data that the user is going to ask by doing an insert with a question. So I can show you that, for example, here in the Discord bot, which is not Notebook LM, but that will give you some ideas. I've built actually a Discord bot, which has infinite memory using an LLM and only Pixeltable. Because all it does is on the fly, as you interact with the bot, it actually indexes the discussion that you're having with the bot itself, which is something that's actually quite difficult to do. If you do it today, there's a lot of projects that are trying to solve the memory management for LLM. And Pixeltable is as easy as just using Pixeltable because of the nature of having the embedding indices collocated with the data and having the unification of your storage, your API calls, and your orchestration itself. So as you can see here, as we are chatting with the bot, we are actually storing the actual conversation in the chat table, but that chat table is actually the one that we will leverage to generate the embeddings to formulate the answers for the LLM. So we generate the embeddings, the LLM is going to query, the column is going to query the right vectors using a similarity search, then feed them into the LLM itself. So there is a closed loop in Pixeltable that enables to make that use case way easier that it will actually be actually be more difficult to do in using another stack, because you'll have to stitch together all those different data store, a vector DB, a data store, an orchestration system, and keeping track of all the conversation logs, keeping track of all the embeddings being generated. So to go back to your question, I just want to show you that example. This is really a way to think about Notebook LLM simply as an application of Pixeltable.
And yeah, and while you were sharing that, someone did ask if you can send the GitHub repo of Pixeltable.
Yeah, I've just shared it below, and I see that there is another question regarding. I've missed this earlier, but does Pixeltable currently support time series data as a modality? Yes, we support timestamp, Boolean, float, all the typical data types, all the use cases. We are, apart if I'm missing something in your question, but we are really focusing on showcasing the multimodal use case, because this is where we believe that there is the most pain points around keeping the data in sync, keeping the different data store in sync, managing the orchestration, and doing the versioning. Today, when you work with different teams or users, most of your media data or unstructured data might be in a blob storage, where most of your metadata will be in our DBMS solution. And so you already kind of two data store that you need to keep in sync. And so you can see Pixeltable not just as a multimodal data store sitting on top of that, but as well the stack where you're going to build your application directly. And by doing that, you benefit automatically from versioning and lineage and orchestration, so that as you build your application, it is already production ready in some ways, because the experiment that you are making, your application is just going to do retrieval call to a Pixeltable in order to power your application. Hopefully answer your question.
Yep, I see a thumbs up.
Sounds good.
So yeah, thanks, Pierre. And I'll say we can always continue the conversation on Discord. So I invite you all there, or check out the lounge if you want to meet some fellow attendees. But in the meantime, Pierre, thanks for presenting this, and I hope everyone enjoys the rest of PyData Global.
Thank you very much. Have a good day. Bye.